Alright, welcome back, and I want to enhance our linear search and now talk about the binary search. So the binary search assumes that we have a sorted array. So I'm going to create a new array. I'm going to call this sorted numbers equals, and I'm just going to list a bunch of numbers here. Okay, I want to get enough so we can kind of see the process here. Okay, that should be enough for us to see. Okay, so this is a sorted array, right? This is all, so in other words, this array has already been programmed to be sorted. Okay, so now I'm going to go to our search. Alright, so I'm going to say this is going to be public static, again, int binary search. I'm going to take the integer data set and then integer target, and here's my implementation. Okay, so part of how the binary search works is that we also need to take the start, the beginning, and the end. So we'll say start and your end. Now this isn't typical. There's no way we can kind of work around this, but it's best that we actually include it in the same function, and we'll use recursion here. Okay, so the basic idea here is we're gonna, because we know it's in the middle, right? So the binary search assumes a sorted array and can therefore continually split our search domain in half, right? So that's kind of the idea, right? So say we're going to look for a number, and we're going to go right to the middle and see if the number is greater than or less than that, and basically cut out half of the other array. So what we need to do then is find the middle. So we're going to say integer middle equals math dot floor, and we're going to take an int. Let's see here. We'll take the math floor div, and we'll take the start and end. Okay, so kind of think through this, right? We're getting basically the end is going to be the length of the array at the first time, right? So when we call this function, so this is call the binary search, and this of course is called the linear search. So when we call this, we're going to call sorted numbers, or not sorted numbers, we're going to call algorithms dot search dot binary search. We're going to pass the sorted numbers. The target, let's search for, let's say 59. We're going to start at position 0, and we're going to end at sorted numbers dot length. Okay, so the first call is going to pass these parameters. Okay, so this is the end. This is the start. So we're going to go from 0 to 59. What's in between the length of those two? Not 0 to 59. 0, position 0, and position, which is the length of the data set, which is about 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have 19. So this will go to 18. Or I'm sorry, it'll go to should go to 9. So we'll go to 9 first. So we'll split this between 9 and 10. Okay. So now we have the middle. Now what we want to do is find the value. So value equals the data set at the middle. Okay, so very simple process here, basically finding the middle value, and then we're saying if the value is greater than the target, we're going to do some code. We'll say else if the value is less than the target, then we'll do some code. Else then actually what we're going to do is else if actually what we'll do is just say if there's a match, then we will just return the middle. Okay, so how's this going to look? So if the value is greater than the target, then what we want to do is actually call this same function again, binary search. We're going to pass the same data set. We're going to pass the same target. But our start now is going to be, again, the same start, which would be, again, in this case, it would be 0. Or no, it would be, so let's think. If the value is greater than the target, then we know that we are in the, we want to actually throw out the other half. We want to throw out that half. So now we want to start at 0 and then go to the middle, -1. Okay? If the value is less than the target, right, so the target is greater than the value, is, in fact, maybe the better way to say it is if target is, this is probably the better way to think through it here. So if the target is greater than, so we're going to split this array right in the middle. If the target is greater than that middle value, then we want to call the same data set. We want to pass, or we want to call the binary search, pass the data set, pass the target, and then we want to start at the middle, and we want to go to the end, the same end that we're still working with. And then if the value is, or if, I should say, if the target is less than the value, then we're going to call the same binary search, pass the same data set, target, but now we're going to start at 0 and go to the middle. And then we'll return middle. Okay, so just to test this out, let's just print each time the value and, or I should say, target. Let's have this be value, and then concatenate. So middle, I want to see the middle index, and then we'll have it print value. Okay, so now let's run this and see what happens. So it's going to print this through each iteration. Okay, so we have an error here, and I think we're in an infinite loop. Okay, actually we weren't in an infinite loop. 0 and 5. Okay, so I think we were, and then it stopped. There's a limit to the recursion. Okay, so one thing we need to do is then account for the middle. So I'm going to have this be middle +1, and then this is middle -1. Actually, this is not 0. This is start. So this runs here. Okay. Still having the same. Okay, let's see what's going on here. So let's debug this and say, this out. Say value is, or say target is greater than value. Concatenate this here. Okay, so a little bit of debugging. Copy that line here, so we'll have to see which function is entering. Target is less than value. Okay. Alright, now we can run this. Okay, let's see. So it's saying 59 is greater than 5, 59 is greater than 5, 59 is greater than 5. So 59 is greater than 5. Okay, let's also print, let's see here, print midpoint is middle, and then value is value. Okay, so let me actually comment this out here. Okay, midpoint was always 0. Okay, so that something is not right in our midpoint. It's not between the two. It's divided by 2. I'm sorry. It's the average. So plus this divided by 2. Put that before we take. There we go. Okay, let's see. Bum, 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 bum. Let's see here. Yeah, I had the wrong function altogether here. So it's not math.floor div, it's math.floor when we want to take it here with a double. Now we might have to cast this. Let's see. Yeah, cast to an integer. So this might mess it up a little bit here. Let's see. Okay. I think we got it. I think we got it here. So my problem was I had the wrong function. So what we want to do is we want to take the midpoint, basically, right? So this is, I should change this in fact to say midpoint to make it even more clear. This is value at midpoint. Okay, so now we have this going. So let's see here. I don't need this anymore. So let's just look at the less than or equal to here. Okay, looks good. Looks good. Looks like it's working fine. Okay, so here's how this is going to work. So let me take out these comments here. Again, we're going to call this function, and we need to give it the initial condition where we're starting and ending, which is basically the whole length. So 0, starting at 0, ending at the length of the array. We're going to find the midpoint, so we need to find the average of the two, the starting and the ending, right? So we're going to take those two together, find it divided by 2, we're going to get the average, and that's our midpoint index. Then we're going to take the value at that midpoint. Now, depending on if our target is greater or less than that value, we're basically going to call the same function and basically go through the whole operation once again. So that's recursion here. So the fact that we are calling the function within our function is recursion. And each time we're basically whittling it down by half. So if we get to the point where it's neither greater than nor less than, then of course we can say that it is then equal, and we found a match. So let's make sure this in fact is the case. I'm going to run demo. Okay, so we have 59 equals 59, and then it keeps on going. See, and the reason is because every time we call the function again, it's actually now kind of going backwards. So we actually want to return this function, right? So we don't just want to call the function again, we actually want to return that value, so we kind of actually get out of the function but call it again. So the way it was working before, when it wasn't working correctly, is actually it was going deeper and deeper into a new function, and then once it got in, right here, it needs to back out and kind of unravel each time. But in this case, we're actually ending the function, we're returning by calling another function. So this is true recursion here. Now we should be able to get this here. Boom, there we go. So we can say return at midpoint. So once again, we can say integer index equals this, and we'll just copy that here. Say index. Okay, now this should work for any number, right? So we can say, let's check, we want to find number 9. That's at position 1. There we go, right? So again, first we're going to 9. We're going to 45 right there. Now we're cutting that half again to 21, and cutting it in half again to 9. Let's try 49. Right, so it took a little bit longer. 49 is greater than 45. So again, it's split right here. and then it saw 49 was greater than 45. Then it split it again right here at 61. That was again the midpoint between 45 and 94. And now we're since 61 is greater than our target 49, now we're looking between 49 and 61. So we're going to go to 51. Again, 51 is greater than, so we're now looking between 45 and 51. So we can make it even more explicit here and say, I guess we were pretty explicit, but we could say searching between say start and end, and we'll see that this continually gets shorter and shorter. There you go. 0 and 19, 10, 19, 10, 13, 10, and 10. Those are the positions. The positions, I don't know if those were helpful, so actually let me enhance this one more time and say the value at the start and the value at the end. Not value, data set. There we go. Okay, now hit demo. And okay, so we had an error here. Let's see. The length, but this might have to be length minus 1, in fact. Yeah. There we go. So now we're searching between 5 and 94. And then now we're between 49 and 94, right? And the 49 and 59. So yeah, so this maybe is a little bit more helpful for us to see the comparison here. So okay, so that's the binary search. Again, it works with a set of sorted numbers, and we use recursion here. And again, the key here is this step here. We take the midpoint each iteration. We test the value at that midpoint if it's greater than or less than the target, and then we return basically the same function, which is we recall the same function, and then use the different points based on whether it's greater than or less than. So this is definitely, and we see when we did the linear search, very, very simple, very easy to understand. When we did binary search, first of all, it cut down on our search times quite a bit because we knew, again, we took advantage of the fact that it's a sorted array. However, the complexity of the algorithm significantly increased from the simple linear search. And this linear search was something we learned on day 5 of our training. This binary search, we used a trick called recursion, and we had to get this midpoint, and so these are things we've never done before. So there's a lot of things we had to think through for the binary search that weren't necessarily as some of it was intuitive. We saw again how we can take advantage of a sorted array, splitting it in half. How do we actually do that? Keep on calling the same function and implementing recursion, stopping when we want to, and that takes a little bit more work. So hopefully you're beginning to see the beauty and the complexity of algorithms and how it can help us.